Welcome back to another explainer right here on Med Medicine. Today, we're diving straight into a really fascinating and honestly deeply impactful physiological cascade. It's called Sheehan syndrome. We're going to map out exactly how a single acute event during childbirth can trigger this massive, rapid domino effect across the entire endocrine system. We'll explore the anatomy, the timeline, and the precise mechanics so you can see exactly how this whole thing unfolds. Let's get into it.
Okay, let's kick things off with a bit of a medical mystery. Why does severe bleeding during childbirth sometimes stop a mother from being able to produce milk? Just take a second and let that sink in. On the surface, massive blood loss from the circulatory system and the physiology of lactation, they seem totally unrelated, right? Why on earth would a hemorrhage affect milk production? Well, as we're going to see, these two systems are intimately connected by a tiny, incredibly vital structure tucked deep inside the brain. Let's unravel this timeline together.
Right, let's build our foundation. Sheehan syndrome is defined as the postpartum necrosis of the pituitary gland, usually occurring following a postpartum hemorrhage. So breaking that down, we're talking about heavy, massive bleeding, a hemorrhage, happening right after delivery, and that leads to necrosis, or the localized death of tissue in the pituitary gland. The literature explicitly links this tissue death to that massive blood loss. But obviously, this raises a huge question. Why the pituitary gland? Like, what makes this specific gland so wildly susceptible to tissue death at this exact moment?
Well, during pregnancy, the body is pulling out all the stops to prepare for motherhood, and a major adaptation happens right inside this gland. The specific regions of the pituitary that produce prolactin, the milk production hormone, they actually undergo hypertrophy. Basically, they physically swell in size to handle the impending workload. It's literally like a factory expanding its assembly line to meet a massive new quota. Because of this localized growth, the overall size of the entire pituitary gland increases significantly during pregnancy. It's this beautiful natural adaptation. But, as we're about to see, this structural change comes with a pretty severe hidden cost.
And that brings us to the vulnerability of all that hypertrophy. Because those prolactin regions have expanded so dramatically, the gland's daily demand for oxygen and nutrients is just off the charts. It is working in overdrive. And this massively increased metabolic demand makes the gland highly, highly sensitive to ischemia, which is a severe restriction in blood supply. So essentially, this incredible natural physiological preparation actually creates a fragile vulnerability. If the maternal blood flow is compromised even for a short bit, well, the gland is larger, it's hungrier, and therefore it's in a much more precarious position.
Let's look at how this builds into the actual clinical presentation. It's basically a rapid-fire domino effect. Step 1 is our trigger event, severe blood loss during delivery, the postpartum hemorrhage we talked about. This massive loss of blood leads instantly to step 2, hypovolemia, meaning there is a dangerously low volume of blood circulating in the mother's body. Now, because blood volume drops so fast, the body kind of goes into a protective panic mode, diverting blood only to the most critical core organs. And that leads to step 3, a vasospasm of the hypophyseal vessels. A vasospasm is a sudden, harsh constriction of the blood vessels, and here it's specifically clamping down on the hypophyseal vessels, the exact lifelines that feed the pituitary gland. Which brings us to step 4. Because those vessels violently clamp shut, the blood supply is cut off completely, resulting in ischemia of the pituitary gland. This is a rapid, dangerous chain reaction happening in a matter of moments.
I actually want to pause the cascade right there for a second. Pituitary ischemia is a critical lack of blood supply triggered directly by that vasospasm. Think about the terrible irony of this biological mechanism for a moment. The gland is at its absolute largest, it's demanding the absolute maximum amount of resources to prepare for milk production, and precisely at its peak moment of need, the hypovolemia causes its specific blood vessels to spasm and completely shut off the supply. The tissue is literally starving for oxygen exactly when it needs it the most.
And so what happens next is the ultimate tragic consequence: postpartum necrosis. Because the hypertrophied gland is completely deprived of vital oxygen-rich blood flow during that ischemic event, the demanding tissue simply cannot survive the stress. The cells within the pituitary gland, particularly those newly expanded prolactin-producing regions, they actually die. That irreversible tissue death is the necrosis that defines Sheehan syndrome. The dominoes have fully fallen now, right from the initial bleeding event all the way down to localized brain tissue death.
So what does this internal tissue death actually look like externally for the patient? Well, the primary clinical presentation of Sheehan syndrome is lactation failure following delivery. And boom, this connects perfectly back to that very first question we asked at the start of the explainer. Why does the severe bleeding stop the milk production? because the hemorrhage caused hypovolemia, which triggered a vasospasm, which caused ischemia, which ultimately led to the necrosis of the exact regions in the pituitary gland supposed to produce prolactin. Without prolactin, lactation just entirely fails. The physiological machinery, our expanded factory, was perfectly prepped for the job, but the power supply was abruptly cut off.
I want to give a huge, sincere thank you to all of you for watching this explainer here on Mid-Medicine. I really hope this breakdown helped you conceptualize the intense, rapid physiological mechanisms at play in Sheehan syndrome. We absolutely love our focused learners who take the time to dig into the structure of these complex medical concepts with us. But before you go, I want to leave you with something to chew on. If a natural, beautiful preparation for new life can become so instantly vulnerable to just a simple shift in blood volume, what other delicate endocrine balances do you think are hiding in plain sight, just waiting for a single domino to fall? Keep asking questions, keep studying those intricate pathways, and I will see you in the next explainer.